In this module, we'll turn abstract KYC requirements into concrete end-to-end workflows. You'll see how document, biometric, and data-only checks connect across services, where orchestration lives, and how to design flows that scale, fail gracefully, and stay regulator-friendly. Modern KYC is no longer a single monolith. At the center, a workflow engine orchestrates many specialized services. One service handles documents, another biometrics, another external registries, and a separate engine evaluates risk. Underneath, transactional databases store KYC cases, while object storage keeps large media like images and video. As architects, your job is to define the orchestrator contracts and data flows, so these components can evolve independently without breaking compliance. Think of KYC not as one fixed workflow, but as a toolbox you tune to risk. Document-based flows use passports or national IDs, giving medium assurance with moderate friction and classic OCR and fraud checks. Video and biometric flows add liveness and live face match, raising assurance for high-value or high-risk onboarding at the cost of more friction. API or data-only checks sit at the low-friction end, ideal for low-risk markets or ongoing monitoring rather than initial proofing. Document-based KYC is a pipeline that turns a raw ID photo into a decision your risk engine can trust. First, a capture gateway standardizes image quality and streams both images and metadata into storage. An OCR and MRZ service converts pixels into structured fields, and an authenticity engine checks for fraud signals. Data validation then cross-checks those fields against internal records and external APIs. Finally, a decision service combines results with business policy to return pass or review. This pipeline only works as well as the images you feed into it. If the capture on the device is blurry, cropped, or full of glare, no downstream OCR, face match, or fraud model can recover that signal. So you push intelligence to the edge, real-time focus and glare checks, edge detection, and basic forgery heuristics, plus secure buffered upload. Architecturally, treat capture as a validation microservice, not just a UX feature. In a production KYC flow, the raw document image is just the starting point. OCR extracts visible fields, while MRZ parsing gives a second, strongly structured source of truth. A parsing engine turns both into a normalized JSON payload, standardized dates, canonical address formats, and clearly labeled attributes. Crucially, it also attaches confidence scores, so downstream services can decide when to auto-approve, trigger step-up verification, or send the case to manual review. Document forensics is really a pipeline of independent checks that converge on a fraud decision. You combine optical checks like hologram and UV patterns, print and font consistency, and edge or laminate integrity with digital signals such as EXIF metadata from the capture device. Each layer is weak on its own, but correlated in a fraud detection service they become powerful, allowing you to distinguish low-quality images from genuine tampering or sophisticated forgeries. Biometrics turn a static ID document into proof of a live, present human. The system extracts the face from the government ID, then compares it to frames from a live selfie stream, while liveness checks look for motion, texture, and challenge responses. When both the match score and liveness score pass policy thresholds, you can safely bind that legal identity to this specific user session and device. Video KYC is essentially a controlled, encrypted video call wrapped around multiple verification services. The customer talks to a human agent, but in parallel, the platform streams liveness checks, face match scores, and scripted identity questions into the agent console in real time. The agent sees structured signals, not just a video feed, and can approve, reject, or escalate. Architecturally, treat this as a specialized real-time adapter plus recording layer, not just generic video chat. When you design biometric or video KYC, treat legal constraints as first-class architecture drivers. Every capture requires explicit, well-logged consent. Storage and processing must be tightly bound to a declared purpose, not general reuse. Retention windows are short and enforced automatically, often with hard deletion. Data flows must also respect jurisdiction, which region stores it, which vendors can access it, and where models run. Your diagram should encode these rules just like any technical dependency. In data-only KYC, your product never directly talks to each external source. Instead, a data provider gateway brokers access to credit bureaus, tax ID services, address databases, and government registries. You send a normalized request, the gateway fans it out, aggregates results, and sends back a unified response. Architecturally, treat this as a high-risk trust boundary and centralize monitoring, rate limiting, caching, and clear failure semantics around this single integration point. Every external KYC provider speaks a slightly different language, different fields, encodings, and error behaviors. A normalization service gives you a clean contract internally. It takes messy payloads, validates checksums, converts formats and codes, and enforces SLA timeouts before anything touches your core KYC case store. Architecturally, this becomes your shock absorber, so adding or swapping vendors doesn't ripple changes across dozens of downstream services. In production, AML, screening names against sanctions and PEP lists is never a simple exact match problem. Customers use nicknames, multiple scripts, and inconsistent transliterations. Your engine needs layered fuzzy matching, normalize data, handle spelling variation, map common aliases, then compare against OFAC, UN, and local lists. The goal is to aggressively catch true matches while suppressing noisy near matches, so only the most suspicious hits go to manual review. The key idea here is orchestration under two very different latency regimes. Anything directly in the user journey must complete within a tight budget, so you prioritize fast checks, document capture, liveness, and a quick registry query that can immediately update the screen. Heavier work, like bureau calls, fuzzy watchlist checks, or manual review, runs event-driven in the background. A central KYC case or state machine ties both timelines together into a single, consistent decision. To wrap up, keep these four anchors in mind. Orchestrate KYC as its own service, independent of any vendor. Invest heavily in capture quality, because bad edge data poisons everything downstream. Normalize all external responses into clean internal schemas. And design flows that gracefully juggle synchronous and asynchronous checks.